Welcome everybody to week 7, day 2. Last time there wasn't a specific IS50B lecture because I hadn't talked about destructible meshes in IS50B in a while, so we just used the IS50A one. Were you guys all able to get the destructible meshes done? That's kind of fun, right? Like you can, like I don't know, you can like click on something and make it destructible, and then be able to blow it apart, stuff like that. Today I guess we'll talk more about the Niagara System. We talked a little bit about this in IS50A, but I'll give you a little bit more on it. I've been playing around with it. I'm not a Niagara expert. I only first started messing with it during the game jam, and I spent probably half the game jam just messing with it and seeing, you know, what kinds of cool special effects you can do in Niagara. I did my character yeets the wall. That's funny. Does it shatter though? When you touch it? Yeah. Okay, that's good then. All right, so we're going to start off, I guess, reviewing trace lines, right? So here we've got third-person blueprint and all of this. Let's see, flamethrower. Okay, so. Quick review of what we did in IS50A today. I created first step, edit, project settings, input, plus to create a new keybind. I typed in alt-fire, and then I binded it. If you click on this little thing here, you can click on that, right-click, and then it binds right mouse button to alt-fire. And I've got left mouse button bound to fire. Once you've done that, then you can come into blueprints and say alt-fire, and you can have code that triggers when alt-fire is clicked and released. And so since this is originally at the beginning of class, I just had it click and it did a trace line and it would explode wherever it hit. That's your basic trace line weapon. But this is a flamethrower, and flamethrowers should be held down to fire. It makes more sense that way. So originally what I had was when you pressed it, it just did a trace line and then did an explosion. But then I changed it so that when you pressed it, it set alt-fire to be true. When you released it, alt-fire was set to be false. And then every event tick, right here, it checks to see if we're firing, and that's the left click. So I said if we're not firing, then come up here and see if alt-fire is held down. If alt-fire is being held down, then we're going to do our stuff. So we do a trace line. It's the standard trace line pattern you guys probably all know and love. We'll just review it really quickly. So the starting point is the thing here. So when you have a skeletal mesh, you can attach sockets to it. What I actually did was I just added a scene component. I went up to add component and chose a scene component and that thing here. And basically the reason why I did that was because that allowed me to just sort of, I parented it to the plasma rifle. So you see how if you drag it over the plasma rifle, it'll be parented and then it moves with it. If you drag it over again, it detaches and doesn't move with it. So when it's attached though, you can just transform it. You just use the little transform tool and move it in front of the barrel. I had to turn off the animation for a second so that it was easy to do. And then I got it like it's, you know, an inch or two in front of the barrel opening. And then no matter where the barrel is, that's where the flame is going to come out of. So doing something like that's a really neat, I don't know about neat, it's a simple way of just marking points. So there's a lot of stuff going on. The guy could be running. No matter where he's running, the barrel opening is always marked. So you can use this to, do you break the fourth wall? Dalton. Nice. Why is it better to create a binding rather than a key event? Because key events, I mean, you can. There's nothing wrong with a key event. But what if you want to allow the player to change their key binds and things like that, right? Plus, it's named, right? And so here we have under project settings. We've got names for everything. We've got move forward, move right, things like that. You could just say when E is pressed, do the flamethrower. That would work fine as well. If we come over here and just did, for example, what's it, key E? It's kind of annoying. Let's see, finding like a letter. That's another reason I don't like it very much. Where are you? Keyboard, touch events, Steam events. Mouse events, there we go. Keyboard event, E, there we go. And so we could do it that way, and that also could do that, and then we save it. Come in here. It got braked. It got broken. So now when I hit E, it does it as well. Okay. But the more proper way of doing it is to create an action event. It gives it a name, and then allows people to, you know, change their keybinds, things like that too. So and also it's kind of annoying to hard code everything like that, because if you ever want to change stuff, then everything kind of gets messed up. Okay. So I'll just get rid of that. But you can do it that way if you want. It's not the end of the world. Okay, so the line trace, this is the pattern we all know and love. Starting position is barrel opening. So I dragged in barrel opening, got its world location, and that is the start location for the flamethrower. The ending location is barrel opening plus the direction I'm looking, which is a unit vector in the direction I'm looking, times, I think, 1,000, 10 meters. So starting location plus the direction I'm looking, 10 meters, that's the ending point. So it draws a line between my starting point and my ending point. And then I'm drawing the flame, my starting point plus about a meter in front. So it doesn't quite get up in the face of the camera so much. And so that is how you spawn a Niagara system, by the way. So we're gonna do Niagara today. If you want to put a Niagara effect into your world, the blueprint node for that is just called spawn system at location. It works just like the emitter thing we've probably done before, spawn emitter at location. This is the old school particle effect system. It's not very good. Niagara is super cool and neat. So rather than spawn emitter, which is the old system, you spawn a system at location, and that will spawn a Niagara system. And I made this thing called Flameboy, and so the location that Flameboy is going to start at is my barrel opening plus the direction I'm looking. That's my forward vector times 100. So 1 meter in front of my barrel, it's going to spawn Flameboy. And the rotation of Flameboy, because it actually has a rotation, it's a cone. It comes out in a cone. The rotation is my rotation. So as I spin around, the flames will come out in the direction that I'm looking. Okay. And I can scale it up or down, which I'm not. And then after that, I do damage to the zombie, which we're not going to talk about today. So the question is this: like, how do you make a particle effect? What kind of options are there? Stuff like that. So I guess we can just make a new one. Let's see. Maybe like an impact effect. So I've already got the flamethrower. I can show you how I did this. But maybe I'll have it, it's like if it hits something, then like it does like a outwards bursting kind of thing. Which would look kind of cool too. So yeah, so let's run through this first. And if you want to ever find your assets on disk, you can always hit the little magnifying glass and it highlights it for you, so you don't have to dig around for it. So Flameboy system is a Flameboy that I right-clicked and choose to create Niagara system and didn't do anything else with. So really all the details are here inside of Flameboy. Flameboy system added nothing. I actually didn't do anything with it. There's stuff you can do with it, but I chose not to. So what we really care about though is Flameboy, not the system. And man, why is that thing running so long? Okay, never mind. It ends at 1.75. Okay. So the way that Niagara works this looks different from other stuff that you've probably done in Unreal Engine, where like even materials are node based and things like that. So the way the Niagara system works is it starts at the top and it goes down, and you can add things to the particle system kind of as you go down. So the emitter is the thing that spawns the particles, and it is there's like categories. So like if you click on this category, it shows the. Let me turn my face off. Let me turn my face off on the stream as well. There we go. So if you were to look at the emitter update thing here, it shows you both emitter state and spawn burst instantaneous. But if you click on the category, then it shows you both of them. So if you click on particle spawn, it shows you all 4 of these things. Add velocity from point, add velocity, which is disabled right now. It shows you all of them, or you can just choose one section at a time. It's up to you how you do it. So starting at the top, click on Emitter Settings. One thing you can do is choose to run it on the GPU, like that. Missing fixed boundaries. Let's see, fixed boundaries here. And then this will have the GPU doing the processing instead of the CPU, which I'm sure you're all aware. If you're in first person, how do you change it to third? You can't. You're going to have to edit the first person blueprint. So all this will work. It'll all work the same way. Except, yeah, you're going to edit the first person blueprint, and basically you're going to see a floating gun. And what you're going to do with floating gun is you're going to, while it's selected, you're going to add component and add a scene component to it there, and then just drag the new scene component to the end of the barrel. And you might have to rotate it also, so that red is always forwards in Unreal Engine, and so that the forward vector is pointed the right way. Okay, so here we got Flameboy. So so I just changed it to be a GPU emitter. Let's just verify that this is going to work. And what you really want is your GPU doing the heavy lifting in your games, not the CPU. The GPU is substantially more. The GPU is substantially faster. That looks fine to me. Okay. All right. So. Yeah, okay. So that's about all that you need to worry about with this, I think. It's like your quality of the particle effects. Yeah, you don't need to worry about most of the rest of that. Emitter Spawn, we got nothing on it right now. You can add stuff to it. Spawn rate, for example, emitter life cycle, fix issue. And so now it comes out in a stream. Eee, check that out. Okay. It's kind of cool. Let's see what that looks like. So you can spawn once. The spawn burst instantaneous does a single burst. A spawn rate spawns over time a bunch of particles. So let's just see what that'll look like. You see that? So the particle hovers in midair, spitting flame. It's not exactly what we want. I mean, it does look cool, but yeah, it's definitely not what we want. Okay, so spawn rate we are going to delete, and we're just going to go back to spawn rate instantaneous. So it'll spawn a little puff of that. Maybe, maybe we could have it. Maybe we can do this for like. Nah, whatever. We'll delete it. Okay. So, so one thing you can do is choose it to loop. So you can have it loop infinitely. And so with one click, what you'll see is a point in space that'll start puffing out fire forever. And in fact, that might be fun to just look at briefly. So if it loops forever, then it will never end. It is the never-ending story of fire. It's kind of cool. I mean, I feel like I'm raving now all of a sudden. I don't know. Okay. Again, not what we want. Does look cool though. And so, yeah, infinite looping is probably not what we want. You could do a multiple looping, and that's kind of what I was thinking of. Like, right now, it is spawning, like if we get 60 frames a second, and we move the mouse really quickly, you'll see gaps in the flamethrower. And so what I was thinking about doing was just having it loop, like a couple times, maybe like 3 times, and have it loop like every, like, I don't know, 100th of a second, maybe. Maybe that's a little too much, too fast. Let's try every 10th of a second. And so this is going to spawn a new flame particle 3 times every 10th of a second. Let's just see what that looks like. So yeah, it definitely feels more fluid. Like we got an actual like puff of like napalm coming out of it now. Do you guys see that? So like for the next 0.3 seconds, it's going to keep spawning even after I click. So before, when I clicked, it would just do like 1 puff. Now it's spawning 3 puffs over time. So it creates a much more fluid look to it. It feels like I'm actually spraying, like, I don't know, napalm or something. I don't know. I like it. It's a cool look. I think I might keep that. And if I move the mouse around really fast, I guess we're still getting, you can see like the frame rate. No. But I do like this look. That does feel very substantial to me. Okay. What do you guys think? Do you like that? Comments, questions, concerns about what we've seen so far? You see over here it's going puff, puff, puff. Puff, puff, puff. So every 0.1 seconds it repeats. You like that look better? Yeah, it feels just like there's like just a mass of water coming out, you know, except it's fire. Yeah. Okay. So yeah, a multiple loop there is useful. Yeah, it's fine. So you can kill it at the end of the. So it's got a timeline set, right? And so you can have it to just kill the particles, or you can let it complete, and once all the particles go away, then the thing turns itself off. So that's what I have it set to right now. But if you want them to terminate early, you can do that. Life cycle, that's fine. Okay, so spawn burst instantaneous. What other options are there? Skeletal mesh. Sample skeletal mesh is kind of cool. Object is warnings. Check the object properties or the message log for details. No mesh assigned. Yes, I know. So, if you were wondering how I got my characters to have how they look like these kind of outlines of skeletons, what I did was I did a sample skeletal mesh. And so I created this really jacked up skeletal mesh like this, and I did this. So if I have my flamethrower sample this thing here, then let's see here, skin on the fly. Source mode. let's see, user exposed variable, make new, do this off the head, skeletal mesh, input skelly, input skeleton, and we are going to drag that over to here. So, let's see. Mesh sampling type. Let's see here. Position offset. Skeletal mesh. So it's going to read this mesh here, and then it is going to spawn particles on it. You know what, let me not combine these two, because it would be kind of weird having a skeleton coming out of a flamethrower. Let me just undo all of this. Okay. Just go back to where we had before. I'll show you how to do that in a second. But that's an idea of the kind of things you can put in here. Okay, so the way these things work is they run sort of top to bottom, right? So first off, it creates an emitter. The emitter is the thing that produces the particles. Then the emitter is going to produce the particles, and that's under the particle spawn section. And so it is going to, for this spawn burst thing here, it is going to, which is going to spawn 750 particles, and we can change that quantity, right, to like, have less particles or more particles. Should look kind of cool, I think. I'll up it a little bit. Then we come down here into the particle spawn system. So for every particle that is spawned, it does this. So right now it is setting it to an orange color, and you can have the colors be random if you want. So we can go into a random range and have it randomly spawn particles with different colors. 0, 0, 0 to 1, 1, 1, and let's see here. Channels. Let's see here. Yeah, so you see we're getting these cool like confetti particle effects because it's sort of randomly rolling the red, green, and blue now on it. Let's see, random keys. So you can randomly, you can have it be orange, but then have it randomly be up or down a little bit. Okay. So anyway, turn these off here. So you can see the hue is you can make it quite randomly different, or you can make it -0.5. You can make it mostly the same with a little bit of randomness in it. And so this particle spawn thing happens when you create the particle. And then there's going to be an update that is going to... So you see how it's like a mass of different colors now? Some purples in there. It's also a lot smoother. I upped the particle count from 750 to 1,000, so it's now a little more voluminous. Yeah, I'm just going to direct set it. Let's leave it all the same color. So it can have a certain amount of mass, and you can have it randomly set or be fixed. the sprite size is pretty important. So so basically the particle spawn is this is a loop, right? So this is going to loop 1,000 times. So for int I equals 0, I is less than 1,000, I plus plus, call this function. Okay? So this particle spawn function is going to be called 1,000 times. And so it's going to initialize its color. It's going to randomly give a lifetime. So we could maybe do something like that. So some of them die immediately, some of them last longer. So you can control how long the particles last. So basically it'll kind of smooth, like some particles will die early and so the thing will kind of thin out a little bit as time goes on. And after 1.5 seconds, they're all dead. So the size, though, is kind of important. So the default scaling is 1, and that creates really tiny, itty-bitty little sprites. And you can see what it looks like if you don't play with that setting here. Right? Very, very... And you can see that I'm triple spawning, right? That becomes quite obvious now what's going on. How it's repeating 3 times. Whereas before it was kind of hiding it with all the volume. So these are single pixel sprites. And I don't know, that might be good for like sand or something like that. But for our purposes, it's not very good. So I played around with it, and you can have random sizes. So you can go from 1 to 100 if you want. And then what's going to happen though is that the ones that are a size 100 are just going to completely obscure the other ones. So if you do want to have randomness, which is fine, put them in a fairly narrow range, because otherwise the big ones are just going to occlude the smaller ones. And there you go. Sprite rotation mode, you can randomly rotate them, except I think they're going to, well, let's try that. Random, let's see if that matters. Because they do scale in the direction that you're moving, so that might direct angle, direct normalize. Yeah. Let me try doing a random on that. Might look nice. I don't know. I'll have to look at that more. Okay, so basically every time a particle spawns, it first initializes its color, its size, its lifetime, and then it gives it a velocity, a starting velocity. And the starting velocity can be given in a couple different ways. I am giving a velocity in a cone, so it's spraying in a 30-degree cone forward. Remember, X is forward. So you can play with these values as well. If you do like a 90-degree cone, it'll be quite wide. And let's try a 45-degree cone, and that's how much velocity you give to it. And again, each particle can have a random amount that helps distribute them so they don't all go to the same place at the same speed. So you can see this is a 45-degree cone, and so it's kind of spraying out a little bit wider than before. Kind of looks cool. That looks neat. Okay. The particles are all randomly rotated now, which I guess kind of looks kind of weird. So I'm going to turn that off. Okay. So add velocity and cone. So when you spawn the particle, you start off with a lifetime, a color, a size, and then you add velocity to it, and it's randomly getting a velocity. And the cone angle, the cone axis is pointed forwards, and then it gets more speed if it's towards the direction we're looking. So the ones off to the side kind of don't go as fast, which gives it a good look. I'm kind of happy with these settings here. I guess I like that. I'm gonna try something weird. I'm gonna try 90 and just see what that looks like, because I'm kind of curious. So let's see what a 90-degree flamethrower looks like. Yeah, it's pretty much blinds you, I think. Right? It's like staring into the sun. Yeah. Like going backwards looks alright, but that's just... Yeah. Oh, you got a laser zombie coming over here? There we go. Yeah, it's just too much. Okay. So, I'm actually gonna put it to 35. I feel like that should be about right. Okay, so then add velocity from point is, let's turn off. You can selectively enable and disable things just to see what each part does. So add velocity from point is like a firework. Baby, you're a firework. Do you ever feel like a, what is it, plastic bag? Yeah. So you can see it's spawning 3 of these. And velocity from point is an explosion. This is very easy choice to make for like a fireball effect. What is it? Kitty Perry plastic. What was it called? Yeah, firework. Do you ever feel like a plastic bag drifting through the wind, wanting to start again? There you go. Some deep lyrics right there. So you see right here, we've got the 3 things spawning, and they're coming outwards in a point. So I would do this if I made like a rocket launcher impact or something like that. So when the rocket hits, then it would explode. I probably wouldn't do the triple thing. I might do a triple thing for like a plasma rifle. It's like, I might make it blue, you know, like I might, you know, if I was doing like a plasma gun, I'd probably do something like that, you know, because that's kind of a cool sci-fi effect, you know. Something around those colors, you know. Like a pulse rifle, you know. Sort of like, yeah, like that, if I was making like a pulse rifle or something. Okay, but yeah, we don't really need to add velocity from point because we're doing a flamethrower. So I've got a little bit of contribution in from it, so it kind of scatters outwards a little bit, but I think I'm just going to turn that off for now and just go only with velocity from cone and see how that looks like. Because I think part of the reason why it's kind of getting back in my face as a flamethrower is because I was adding velocity from point. So this is now just cone velocity. So you see this is not, I guess it's still, if I run forward. But before, even if I was just firing, like, yeah, path around there, dude. You got no line of sight to me. You have no power here. So now this is all just cone velocity. What do you guys think? Do you think it looks better this way? I might turn off that triple thing. So when you move it around, it's pretty visible what's going on here. Do you like just cone better, or do you like it better before, where it was kind of exploding outwards a little bit? Are you worried about the frame rate? GPUs can simulate like 1 million particles at a time. Like, it's not actually too bad. You know, like this is buttery smooth. The foliage actually has a worse impact on my frame rate. You know. So, what do you guys think? Do you like just cone, or do you like what I had before with the cone and velocity? Or the cone and point? You like this one better? Okay. You like this one? Okay, so, and then I'm going to turn off this looping thing. I think I'm just going to do it once. Because there's kind of an artifact when you're looking up, you can see the 3 things spawning. So rather than doing that, I think I'm just going to throw more particles at the problem. And see if we can get the same buttery smoothness of a flamethrower that way. This one looks more accurate. Yeah, so there we go. We got more particles coming out at once. can still see it's happening every frame. It's not bad though. Okay, so come back over into Flameboy. All right, so, and then you can just add velocity if you want. So if you want to move, have it all come forward more, you do that. Then it's just going to add a forward velocity to all the particles. Did I save that? Yeah, I did. Okay. Yeah, so that'll have it kind of shoot out a little bit faster on all of them. Yeah, should be good. Okay, so basically the emitter is going to spawn 3,000 particles for each of the things. It's going to kind of run down the line here, and then particle update runs every frame. So basically every frame, each one of those particles is going to have physics run on it. Okay, so all of those 3,000 times if we're doing 60 frames a second, so that's 180,000 particles per second we're making. This thing lasts about 2 seconds, so it's about 360,000 particles we have on the screen at once with the flamethrower. No problem for the GPU. If we did this on the CPU, it might eat the frame rate. That's why you want to run it on the GPU. Okay. So so this runs every frame, and it's going to do all of these things every frame on all 360,000 particles. Okay? So, first of all, kill it when your lifetime's elapsed. That's kind of important. Gravity force. So you can have gravity apply upwards if you want, and then the flames will rise, which is kind of a cool effect. You can have them fall quite fast. You just have it sploot out like that. You can have it neutral, where they just don't fall at all. I think it looks good with it pulling down just like a little bit, right? Because that makes it feel like you're shooting like napalm, you know, that is kind of getting pulled down. And I had it at negative 400, but I'm thinking that like maybe negative 200 looks a little better, because then it'll feel like an aerosol more than like water. So right now it feels like I'm kind of shooting water out, which is okay, but I just want to, yeah, you see how it's still drifting down, but it's kind of hovering in the air a little more, you know. So this feels more like I've lit a can of hairspray on fire, you know, whereas before it was kind of splashed into the ground more, and it felt more like liquid fire. Which one do you guys like better? Negative 200 or negative 400? Or we can go even higher. 980 is technically gravity. 9.8 meters per second squared. Flaming Febreze. Okay, alright. Alright, so there we go. Then drag slows these things down. If we turn off drag, it'll just fly forward. Okay. If it was 0 for gravity, it would just fly. It would keep its initial velocity. So the particles here don't slow down at all. This looks a little unnatural. I think they feel better with drag. Yeah, if we set gravity to 0, then it's just going to come out straight. Because it has the velocity from the cone and the linear velocity. So these things don't. You see how that? Okay. Which some video games do it that way. I do think it looks a little bit more natural, having the particles getting sucked down a little bit, you know. Okay, drag slows them down. Scale the color, so you see how it like is bursting in color and changing color over time. You can play with all that. You can have it like turn gray after a while, or turn into smoke after a while. You can have it go transparent over time. So let's see, lerp vector. Let's try that. maybe. So 0 to 1 scale RGB. No, that's just an average. We wanted to do it over time rather, so not a lerp vector. We want to vector from float. No, vector from curve. Okay. So over time, red, green, blue. I want all three of these. Yeah, so let's delete that curve. Let's delete that curve. Okay. So all three of these are going to maybe do that. Maybe do that. Let's see. Let's just see what that looks like. So the red is going to go from here to here. Yeah, whatever. Just turn off scale RGB. So the alpha, though, is going transparent over time, so it kind of goes transparent. I'm just going to leave the colors the same. I don't have time to play with them too much. But yeah, you can play with those things and have them, you know, change. Like I've done in games in the past. Like the fire comes out and then it turns black and then it sort of dissipates. So there's like fire and then the fire burns itself out and turns into smoke. And not using Niagara, but in other particle systems I've done that. And it works pretty well. Okay, so solid forces and gravity just means physics runs. Scale sprite size by speed. If you look really closely at these sprites, you'll see they're not circles. If I do this, they're circles. If I do this, they come out as ovals. And so the faster the direction they're moving, they kind of stretch in that direction. And I don't know if it's exactly a realistic effect, but it kind of looks cool and it adds like a visual sense of direction to it. So I'll leave that on there. 20, 30. So you can see how, do you see how, I don't know if that's coming through on the stream. Do you see how they're like really elongated like that? So, yep, so you can stretch them in the direction they're going, and there's all sorts of things you can do. Skeletal Mesh allows you, to, again, to attach particles to a skeletal mesh, like the laser zombies. Add event handler, so you can do. Then it renders it. Default sprite material is the actual dot, which is just a dot. It aligns to face the camera because these are just 2D pictures, and so they always face the camera. And that's basically that should. Oh, yeah, I'll leave that off. And then that, you know, and you can give the quality setting on it. And there you go. So that's Flameboy. Okay. And after you create a emitter, so the step you're going to do for this is right-click, FX, create a Niagara emitter, and you go through that process. And you can actually start with a fountain or a blast or particles hanging in the air for dust or a laser beam. They've got different options that are going to give you a good starting point. So just pick something that's in the general idea of what you want. For example, for my laser cannon, I started with a dynamic beam and then I modified it a lot. And so that one looks like this. Okay. So I've got a laser beam, and when the laser beam hits things, then it also spawns an emitter that has two different particle effects. One is that little cloud, the white cloud, and then the other one is like a blue fountain. And so together it kind of adds like a little bit of stationary like rubble around the point that's being hit. And then it's got like sparks coming off, like plasma laser sparks or whatever. So the flamethrower looks pretty sweet right now. Okay. All right. Okay, so let me show you. Okay, so after you make your emitter, first thing is you make a Niagara emitter, and then you add it to a system. Okay, so a system is comprised of different emitters, and so the easiest way of doing that is right-click, create Niagara System, and then it just makes the system for you, and everything's good to go. So that's all you have to do to get it working in a blueprint. So now that I've got Flameboy System here, then inside the third-person character blueprint, I say Spawn System, and I pass in the Flameboy System, and just everything works. So that's the process from start to finish. There's a couple important things though to add on to this. First of all, is how you can pass parameters to the system. And for example, when I click, what's happening is when I left click, I've got that laser beam that's coming up. So I'm doing a line trace, and then then tech branch cast laser point. Let's see if I'm doing anything. No, this isn't tied in with the emitter. So I'm gonna go take a look at the laser boy. So the laser. So that. Oh, I see. Yeah. Okay. All right. So Laser Boy is actually a blueprint, and so my third-person character has Laser Boy attached here, and it's actually it's a Niagara emitter, basically. It's a blueprint that is going to, when every second, it is going to be doing a trace line out of myself. It does a trace line, and then if it hits anything, then it moves. This is how you connect. Okay, let me rewind. You can connect blueprints with Niagara systems. Okay, so there's a node in blueprints called set vector parameter, and you have to type in the name of the vector parameter very exactly, or it won't work. But basically, you can attach a particle system to so this is I've got two different particle systems. One is the white glowy cloud, the other is the fountain effect. And actually, no, sorry, that's both of those. The laser is actually the beam. And so what I do is the beam has a parameter for the ending point on it, and what I'm doing is when I contact something, I set the location of the ending point of the laser to be the end of the trace line. So I do a trace line, and if I hit something, then that parameter gets set to be the point the trace line hits. If I don't hit anything, then it is just the end point. So the end point of the trace line, if I don't hit anything, that's the place the laser draws to. If I hit something, then it turns on visibility on the impact, so it draws the cloud, it draws the smokes. If I don't hit anything, then it turns them off. So basically, as long as I'm holding down fire, the laser appears. The impact appears only if I hit something. So let me pull up the blueprint for that. So we've got here laser emitter, and laser emitter's got two parameters here. One is the color, which I don't really mess with. The other is laser end. Laser end is a vector, and so that's how you connect. That's how you connect the particle system with blueprints. There's the thing where you can set vector parameter, and so I'm telling the Niagara system where the end of the laser is. The beginning of the laser is just its origin, and so it's going to draw a beam of color to, where is it? That's color. Let's see, beam width is 15. Let's see here. There. And so it is going to start at its origin, wherever it is in the world, and it's going to go towards whatever value is passed in here. And that, so the third person character has a laser boy. The laser boy is running every tick, and it sets the location of the endpoint to be the end of the trace line, basically. And that's basically it. Laser boy turns on and off. So if I'm not firing, laser boy gets hidden, so it doesn't draw the laser beam. When I press click, then it turns laser boy on, the laser beam appears, and then every frame that it's visible, laser boy runs a trace line and sets the ending point of the laser here, which comes in here. It sets the ending point to be the end of the trace line. And so that's how you have lasers work. So that's the glue right there. That's the glue. And so Laser Boy has two Niagara systems that's part of it. One is Niagara Laser, one is Niagara Impact. I could have just attached all of these things to the third person character. I could have attached Niagara systems to it and individually turn them on and off, but it seemed easier to do it this way. So all I have to do is turn Laser Boy off, and then all three of these go away. Okay. Then for the skeletal outline thing, the body shell thing here, it has the color as a parameter, and it's got a skeletal mesh as a parameter as well. And so the skeletal mesh is it's going to read that skeletal mesh passed in here, and it's going to spawn particles all along the mesh. It's going to spawn 10,000 particles. So it's going to simulate, that's what's causing those laser zombies to look like this. So it spawns 10,000 particles along the outline of the skeletal mesh. And which skeleton? Well, that's a parameter. So you can use the same Niagara effect for the player, like this, with just different colors. I'm using blue for the player, and I'm using red for the laser zombies. So I call this Niagara Outliner, and basically the parameter for the skeletal mesh here is me. So I say attach to the parent. So I attach it. So the Niagara Outliner is a child of the mesh. And so it's reading the mesh of the parent. That gets passed in as the parameter here. Then the code here, which does the mesh reproduction sprite that outlines the skeletal mesh with particles. And then over time, there's a little bit of color fading over time. That's why the laser zombies kind of vanish and then come back. And then every frame they update. So as the people run around and animate, then every tick, right, every frame, the particle updates, and it follows the mesh as it animates around. So it's again the parent. And so, yep. And so as the person runs around, then the particles follow them. That's it. It's a pretty cool effect. So what I'd like for y'all to do for next Tuesday is do I don't know. What do you guys think? Now that you've learned kind of the basics of Niagara, what do you want to do for next Tuesday? So I think it's kind of fun. So you can see on here I've got the blue dots sort of following my character around. And that's because I have attached that particle. Like, you can actually add, I haven't shown you guys this, add a Niagara particle system. You can actually add a Niagara particle system to your blueprint. And so I added it and I parented it to the mesh. And so you can see here I can change the colors because I set my color as a parameter. And so I can make it more green or white or whatever. And if I do that, then I'll have a white outline around the guy. I think I just made it white accidentally. Dang it. Why is undo not working? Edit green. Edit green. I don't know what's going on anymore. Okay, it's back. I'm sure it's fine. Let's see if I broke anything. Roblox. No, like as far as Niagara goes, what do you guys want to do for your homework? Do on Tuesday? Make a flamethrower, like the IS-50A people are doing, or do you want to do some skeletal mesh outlining? What do you feel like? Make a flamethrower. You just want an easy IS-50A assignment. No additional challenge. No laser beams. The laser beams, to be fair, I didn't really go over it very, very closely. So that's fine, I guess. But maybe the skeletal mesh thing. I don't know. You're gonna make an acid thrower. Okay. You don't mind either way. Okay, why don't I give you guys slightly more difficulty than the IS-50A people? So I'll have you make both a flamethrower and do the skeletal mesh outlining. Do you guys still have the animations in your in your world? Oh, there's Stephanie's artwork. Thank you. Do you guys still have your dancing skeletal meshes and things like that? Any sort of animations? You can even use the first person blueprint, and all you have to do is just attach a Niagara emitter to it. It's like what I did for the laser zombies was zombie blueprint. So I've got here the mesh. The mesh is set to be invisible. So that's actually what it looks like if I turn off the... If I turn off everything, this is actually what the thing looks like, which is actually kind of creepy, huh? And so what I did was I have the mesh, and I turned it off. I made it invisible. And I just clicked on it, hit Add Component, Niagara Particle System, boom, which Niagara Particle System, Glow Shell. And Glow Shell is just the name of that thing that I showed you right there, that it reads in the its parent skeleton, which is that. It reads that in, and then puts 10,000 points randomly around the mesh. And so it outlines the mesh with dots. So, turn you edit visible, edit visible, edit visible, edit visible. The shell on, and the dust shell is a different particle effect that I really don't want to save that one. When they die, it turns into dust. I don't know if you guys can see it. That is nightmare fuel. Thank you. It's a laser zombie, dude. So watch, when it dies, it's going to turn into like this white dust that dissipates. See that? And it keeps running forward towards you. Yeah, let's come over here where it's dark. See that? So it actually turns into like this white dust, and it keeps running at you. And it actually hits you even when it'll push you. Even when it's dying, it sort of fades apart and smashes into you. So that's a different particle effect too. But basically, yeah, that works the same way. So the dust shell takes in a mesh as a parameter. That's the thing it just gets from its parent. Takes in a color, and then it does the mesh reproduction sprite. It spawns 10,000 particles attached to whatever mesh you pass in, and then every frame it re-updates with the mesh reproduction sprite thing like that. And the laser zombie simply attaches that Niagara system to the mesh. You click attach parent here, that's the key thing, that's what links the two things together. So that parameter sk mesh is the parent. The parent is mesh. And so that connects the two systems together. I've got the color set here. The glowing shell is that the laser zombie color is this kind of shrimp color, and its mesh is the parent. That. And yeah. Skin on the fly. There's some other thing that's important. To get the animations out of it. I don't remember off the top of my head. Sometimes it doesn't animate properly. So if the animation isn't following it, let me know and I'll require current frame data. That's not it. Something to do with the getting the current bones and things like that. Like sometimes you'll see them just T-posing, and if you do that, contact me. Let's see here, mesh, animation mode. That one, right there. Okay. So under the mesh itself, you have to always tick pose and refresh bones. And the reason why you need to do that is because I'm not drawing the mesh. So I've got an invisible mesh. And so normally the game just optimizes any of the animation away because it's not visible. And so what happened is it would just the things would just be sliding around, not animating. And so on the mesh itself, because it's invisible, you don't have to do this, I think, if it's visible, but you need to choose always tick pose and refresh bones, so all the bones move around every frame, even if it's not visible. That's because the particle system pulls that data out of it every frame, and they move the particles around to match the mesh. Okay, so that's the last bit there. I'll post, I guess, some YouTube tutorials on how to do the skeletal mesh thing, because I sort of did it kind of a half-assed fashion. But the flamethrower you should be able to do. So there'll be 2 parts. Make a flamethrower. That's half an hour's worth of effort, if that, and then make a something that wraps around the skeletal mesh. I've seen people do pretty cool stuff with it. I just made the laser zombie. I hid the mesh and did that to create that kind of cool effect. But I've seen people like have people running around on fire, you know, and stuff like that. So there's a lot of really cool stuff you can do, and I'll link you a YouTube video on that. It's not too bad. The essence is, again, you attach the mesh, the Niagara effect, and the Niagara effect has a parameter right here. You just click plus, add a variable type skeletal mesh, and then that gets dragged to here for the mesh reproduction sprite. That's the glue. That's what links the particle system and the animation system together. You do that, and then everything works beautifully. Okay, so that's it for today. Sorry, we went 20 minutes over. It's 4:23 somewhere. So it should be fun for you though. Like I hope you're having fun in this class to begin with. I know the programming side of things, some of you haven't programmed in a while, and it could be tough doing the Voronoi and stuff like that. And if you haven't finished them, by the way, just turn them in like by the end of the semester, I guess. I'm really not too punitive in this class. If there's any assignments you guys haven't done, like, just do them, you know. And I wouldn't wait till the end of the semester, because that's when the projects start getting due and things start piling up. So just get done anything you're missing, because not all of you have an A in the class right now. So if you're missing any of it, if you're missing any of the programming stuff, just do it and tell me when you do it, and I'll give you the points on it. But yeah, seriously, I hope you're having fun with this. We're doing more advanced stuff than what we did in 50A, and I know the game jam was pretty stressful for some of you, but you know, it's also probably valuable life experience, you know, as far as like working on teams and under pressure and stuff like that too. So how big should the scope of your mod be? Just talk to me about it. You know, it's a class with like 5 people. It's fine. Just message me. Not too big, not too small. Something suitable to your skill level. Twice the size of your old one. Are you doing Roblox? Okay. Do that. Minecraft. Okay. Sounds good. I look forward to seeing what you guys do. Okay. That's it. I'll see you guys next time.